Good morning, everybody. Today, I will explain you momentum or the quantity of the motion. You see, what do you mean by the quantity of the motion? Quantity of the motion. And in the case of the motion, mass and the velocity. That is a motion. Force applied on an object, it moves. And in the same direction, that is the velocity. So quantity of the motion is the mass and the velocity. So momentum is the quantity of the motion. This we can explain by taking an example of the two balls of the different masses or of the same masses. In first case, if we take two balls whose mass is m1 and the m2, suppose one is cricket ball, other is tennis ball. M1 is the more mass of the cricket ball, m2 is the less mass of the tennis ball. If both the balls they were thrown with the same velocity, in the same direction, we find that more force is required to stop the ball of the lower mass and the less force is required to stop the ball of the less mass. So from this we conclude that force is directly proportional to mass. Again listen, cricket ball more mass, tennis ball less mass. They are going with the same velocity. We find that the more mass is required to stop the cricket ball, that is the more mass, and the less force is required to stop the tennis ball, that is the less mass. So from this we conclude that force is directly proportional to mass. Now take this example in another way. If the two cricket balls of the same mass, they were thrown with a different speed in the same direction. Here mass is same but the speed is different. Again here we find that more force is required to stop the ball of the higher speed and less force is required to stop the ball of the less speed. Here again we say that force is directly proportional to the velocity. It is a vector quantity. So here we find that the quantity of the motion that depends upon the mass and the velocity. So quantity of the motion depends on the mass and the velocity. That is, momentum is equal to mass into velocity. Momentum is equal to mass into velocity, and the SI unit is mass is kg, velocity is meter per second. So SI unit of the momentum is kg meter per second. Now what is the relationship of the force and the momentum? You know, force is equal to mass into acceleration. If a mass of body m whose initial velocity is u, final velocity is v, acceleration is a, time given t, then acceleration is equal to v minus u upon t. That is final velocity minus initial velocity upon time. That is the change, rate of the change of the acceleration. Now putting the value of a, f is equal to m into v minus u upon t. So f is equal to mv minus mu upon t, and this mv, that is the final momentum, mu initial momentum upon t, that is the rate of change of the momentum. So the relationship of the force and the momentum is that f is equal to rate of change of the momentum. So this is force and this is the rate of change of the momentum. So force is equal to rate of change of the momentum. So it's a very good definition for the momentum or the quantum motion. Remember only that quantum motion depends upon the mass and the velocity. Quantity that is of the motion, that is mass into velocity, and this is known as the momentum, mass into velocity, and SI unit is kg meter per second, and the relationship of the force and the momentum is force is equal to rate of change of the momentum. I think it is very clear to you about the momentum. If you like my videos, please share and subscribe. In my next video, I will explain you conservation of the momentum. Okay, thanks very much.